Set notation and more. There are three notations we're going to look at when we're talking about a set of numbers. First is the one that you're probably most familiar with, and that's inequalities. When we talk about inequalities, we use either a less than or equal to sign, and a greater than or greater than equal to sign. For example, we can say that x is less than 60. We could also say that y is greater than or equal to, actually we'll make this a little more interesting. We'll say negative 20 is less than or equal to y, which is less than, say, negative 10. For the first example, this means x can be any value that's less than 60. We assume that x is then an element of the real numbers. And we assume here that y is an element of the real. So here we have an assumption that we are using reals. This brings us to our second possible way to notate sets, and that's interval notation. In interval notation, we use either rounded parentheses or square brackets. The rounded parentheses is equivalent to a less than or greater than with no equal sign. The square brackets is equivalent to having that equal sign below. So for example, if we wanted to say something equivalent to the fact that x is less than 60, this would be saying that infinity, we're going to take all the numbers from negative infinity to 60, but we are not going to include 60, so we're going to use this rounded bracket. And this tells us x can be any value from negative infinity to 60. We always use a rounded parentheses for positive or negative infinity. Let's say we want something equivalent to what we saw up here with negative 20 is less than or equal to y is less than 10. Well, we're going from negative 20 to negative 10. We are going to include negative 20 in our set, so we'll use a square bracket. And we're not including negative 10, so we'll use that rounded parentheses. Again, the assumption here is that we are using the reals. Unless we indicate otherwise. But these two are our interval notations. So what happens when we want to use something other than the reals? Well, this brings us to set notation, which is where we use these curly Q brackets. Set notation is great because we can express a finite set, such as 1, 2, 3, 18. Or we can say that we want every number x less than 60. And we're going to define, though, what element x is a set of, or what set x is an element of. So we're going to say explicitly that x is a real number. Or we can say that we want all the numbers between negative 20 and 10, such that y is a real number. Let's say we only wanted the numbers 4, 5, 6, 7, and so on. Well, we could express it in brackets like that, or we could say that we want all the numbers x greater than or equal to 4 such that x is a natural number. So we'll take all the integers or natural numbers from 4 and above. So these two sets right here are equal. I know the set notation is a little complicated. The basic thing you need to make sure that you remember is that this line right here means such that. And it's how we add a restriction or a definition or further explanation to the end. You also need to realize that this symbol here, it looks like a 0 with a line through it, means the empty set. And is the same as two brackets with nothing inside. It means the set has no elements whatsoever.